Assalamualaikum warahmatullahi ta'ala wabarakatuh. Welcome to another video on MCTA 2311 Signal and System Analysis. So in this video, we will continue our discussion on Fourier Series. Okay, where I will show you the solution to another sample problem with regards to Fourier Series. Okay, so in this question, you are asked to determine the trigonometric Fourier series representation of the given signal, okay, shown in this figure. So the first thing that you wanted to do, okay, to solve this kind of question is first determine the mathematical definition of this signal. Okay, so for this signal, which is f of t, the mathematical definition, okay, is equals to so let's have a look at the period of the signal. Okay, so for every 2 seconds, okay, the signal is repeating the same pattern. Okay, so the period is 2 seconds. Okay, and if you look from 0 second to 1 second, the shape of the signal is like this. Okay, and from 1 second to 2 seconds, the shape of the signal is like this. Okay, so it has different shape. So it means for the mathematical definition of the signal, we have 2 parts. Okay, so the first part is when t is in between 0 to 1. Okay, so the signal is a ramp signal like this. So f of t is equals to t, okay, at this time range. The second one is when t is between 1 to 2 seconds. So from t goes to 1 to 2 seconds, f of t is 0, given by this straight line. Okay, so f of t is 0. So the next thing is to determine 2 parameters, which are the period and also the radial frequency. So period is 2 seconds. Now, radial frequency is given by the formula 2 pi over t. So in this case, 2 pi over 2. So we have pi radian per second. Okay. So now that we have the mathematical definition of the signal and also these 2 parameters, we can proceed with calculating the coefficients of the trigonometric Fourier series. Okay, so let's first have a look at the general form of the trigonometric, okay, Fourier series. Is given by this equation, where f of t is equals to n naught plus summation of n equals to 1 until infinity for a of n cos n omega naught t plus bn sin n omega naught t. Okay. So these are the parameters that we have to calculate, or the coefficients, okay, that we have to calculate: a naught, an, and bn. Okay. So for for n naught, we calculate using this formula. A naught equals to 1 over t integration over 1 period f of t dt. So if I substitute 1 over t is 1 over 2, so the period is 2 seconds. Now we have the mathematical definition is divided into 2 parts. So we integrate from 0 to 1 second, f of t is t dt, plus for the second part, 1 second to 2, f of t is 0 dt. So it means this part, the whole thing will become 0. So you are left with 1 over 2 integration from 0 to 1 t dt. So if we integrate this part, you have 1 over 2 t square over 2, and the integration limit is 0 to 1. Now you substitute 1 and 0 into t, you will get a naught equals to 1 over 4. Okay, then the next coefficient is an. Okay, so an we can calculate using this formula. An equals to 2 over t integration over 1 period for f of t cos n omega naught t dt. Okay, so if I substitute the t and omega naught, I will have here 2 over 2, and then integration over 0 to 1 f of t, we have t. Okay, cos n omega naught is pi t dt plus integration from 1 to 2, f of t is 0 cos n pi t dt. So it means this term, the whole thing will become 0. So we are left with an equals to, and this one cancel out. So we are left with 0, 1 t cos n pi t dt. Okay, now I hope you still remember how to do this integration. Otherwise you have to refer back to your calculus textbook. So if you integrate this, you will get t sine n pi t over n pi plus cos n pi t over n pi square, integration from 0 to 1. Now, the next thing that I wanted to do is make the denominator equal, so I can add both parts. So I have, and this will be n pi sine n pi t plus cos n pi t divided by n pi square, integration from 0 to 1. Okay, and I can put aside, the n pi square, and I substitute t first with 1. Okay, so here I will have n pi sine n pi plus cos n pi minus, I substitute this with 0, so the whole thing will become 0 because this t here is 0. Okay, so I have minus 0 and then minus, substitute this t with 0, I will have cos 0. Cos 0 is 1. Okay, now when you arrive here, you wanted to refer, to the table on the value of sine n pi and cos n pi. This table will be given in your exam. Okay, so for sine n pi, the value is 0. Okay, so this one, sine n pi equals to 0. So the whole thing here will become 0. Cos n pi, the value is minus 1 to the power of n. So this will be minus 1 to the power of n. Okay, so here the whole thing will become 1 over n pi square multiply with minus 1 to the power of n minus 1. Okay, so an equals to minus 1 to the power of n minus 1 over n pi square. So the next coefficient to calculate is Bn. Okay. So for Bn, this is the formula. So it's again 2 over t integration from 0 over 1 period for f of t sine n omega o t dt. So if you substitute the value, you get 2 over 2 dt plus here 0, okay, because f of t is 0, okay, when the integration from 1 to 2 seconds. And this one you cancel out, so you are left with integration from 0 to 1 t sine n pi t dt. Okay, if I integrate this, okay, I will get, integrate sine, you will get minus cos, so minus t cos n pi t over n pi plus sine n pi t over n pi square, integration from 0 to 1. Okay, so again, what I will do is make the denominator equal. So I will have Bn equals to minus p n pi cos n pi t plus sine n pi t over n pi square, integration from 0 to 1. Okay. So if you substitute, let's take out the n pi square and you substitute the numerator, okay, in the t in the numerator with 1 and 0, you are left with sine n pi minus n pi cos n pi minus sine 0, then minus to minus, it will be plus 0, because here the t here is 0, so the whole thing will become 0. Okay. Right, so again, when you arrive here, you refer to the table. So for sine n pi is 0, so this part will become 0. Cos n pi, it will be this one, minus 1 to the power of n. Sine of 0 is 0. So you are left with Bn 1 over n pi square. You will have minus n pi to the power, multiply by minus 1 to the power of n. Okay. And this one can cancel out with this. So you are left with minus 1 to the power of n over n pi or you can rearrange this to become minus 1 n plus 1 over n pi. Okay. So we have all the coefficients that we needed. So now we can write the trigonometric Fourier series representation of the given signal, which is f of t equals to a naught is 1 over 4 plus summation from n equals to 1 until infinity for an. An is minus 1 to the power of n minus 1 over n pi square. This one multiply with cos n pi t plus bn. Okay. Bn is minus 1 to the power of n plus 1 over n pi. And we have here sine n pi t. Okay, so this is the trigonometric Fourier series representation of the given signal, okay, which is this signal. Okay, right. So that's all for the video this time. I will see you in another video for another sample problem on Fourier series. Thank you.